I had bought a house that was way out in the wheat fields, and that year we had a major stripe rust epidemic that came through, and there was a supposed race shift in the stripe rust, and it wiped that variety out. And I remember walking out of my house and looking out on wheat fields that were just stubble, basically.
In 1968, I read a book, The Population Bomb, which predicted there would be massive famines. And it basically described a world in which I did not choose to live. Basically, it's a world that you have to change. You cannot accept that vision of what the future is.
Many of the past famines have resulted from sudden susceptibility to a new disease or a new insect.
The biggest one that comes to mind is the Irish potato famine with potato lake blight.
The Europeans discovered potatoes and how tasty they are and how easy they are to grow, and so they took them to Europe. And then, of course, they ended up over in Ireland, where they became the sole source, almost the sole source of food for the Irish people. And then this little old organism called Phytophthora infestans hitched a ride on one of those potato shipments from Central America over to Europe, where the varieties there that were growing in Europe were pretty much the same genetic base, as opposed to, in Peru, a great diversity of genetics, makeup of the natural potato, and the fungus could only attack some and not others, but when it got to Europe, it could take out the whole crop.
Plant diseases are significant for agriculture as a whole, and so it's estimated that worldwide about 30 to 40% of crops are lost per year to diseases and insects. So this isn't just sort of a side issue, it's really a major issue for agricultural production.
We have many different biotic constraints to our crops or cereal crops throughout the world, whether they be fungal, bacterial pathogens, virus, or nematodes.
Plant pathologists usually try to find ways to protect plants from those diseases.
Stripe rust, which is a major global disease in wheat. So it's something we put a lot of effort into in our plant breeding programs. And as what stripe rust is, it's a fungal pathogen. And so the fungi produce spores, and those spores will come and land on the green leaf tissue of our wheat plants. And as those spores begin to grow, they begin to take the photosynthates or the carbohydrates that the plants produce, which typically go towards making grain and making a high yield, and begin to take it for themselves as they grow. So you get a green leaf that, as this fungus infects it, begins then to die. And without a live leaf tissue, the plant's not able to produce a high yield.
When a pathogen arrives, that's a different situation, and you cannot recover from that by simply growing more of the same. You have to make a change in what you're growing.
And one of the most important biotic constraints that we're working on now is a fungus disease called stem rust. So right now we're facing an outbreak of a race called UG99 that originated in Uganda in 1999. And what scientists have found out now is that this race is capable of destroying about 70% of the world's wheat cultivars and over 95% of the world's barley cultivars. So this represents probably one of the greatest threats to agriculture that we currently have in the world today.
Plant breeding is really, in very simple terms, it's the idea of creating variation and then selecting upon that variation for whatever trait that you might be interested in. So when I talk about creating variation, that might be where we take two plants that might be a very high yielding plant and we cross them together. So we take the progeny from that cross that has all the variation, and then we can take it out to the field and begin to select upon that variation for whatever trait we're interested in.
So the genome is very large, and at different parts of the chromosomes you could look at it as, say, road signs, and those road signs basically might be very close to a resistance gene that's present on that chromosome. So when we have these road signs that are attached to these genes, we're able to develop markers so that we can look across a genome and say that this variety has this sign which is associated with this gene.
If we're able to breed crops for disease resistance, it means that we don't have to apply pesticides on there, and the only thing the farmer has to do as far as the input is to plant the seeds. So we view the development of resistant cultivars as one of the more sustainable ways to maintain crop production without the addition of pesticides or any additional inputs by the farmer.
So looking ahead to the future is one of the most important jobs of a plant breeder. When we're developing a variety today, it's not going to make it to a farmer's field for at least 5 to 10 years.
Plant breeding is not just an instant, I've got a disease and tomorrow I can have resistance in the crop. It really takes time and a process, and so we have to start now to begin looking forward for some of these resistances and really using as much technology as we can to speed up that process.
It's so easy to think that there's no problem for food. After all, we can feed New York City every day, and nobody there grows their own food. And we can feed Chicago and Los Angeles and Washington, D.C. and Atlanta and all the cities, big and small and in between. And nobody even worries about whether that supermarket's going to be full of food. But that's not the way it is around the world, and that may not be the way it is in the U.S. someday.
And it's right now, I think, very important because we're seeing these changes in the climate. We don't know what to expect. There's changes in disease spectra. We're seeing new races of rust that we've never seen before that are causing global food security issues. And unless we come together as a nation and as a global community to combat it, we might see some major food security issues in the near future. And it's something that needs to be taken seriously.
So we've got to stay ahead of this ugly beast that's out there, that's looming. And you know, you're just an alarmist. But believe me, we've seen what can happen. And we've got to stay ahead of the curve. And plant breeding has got the tools to do it.